Here are two examples of writing a Maclaurin and then a Taylor polynomial. In this example, we have a function f of x equals cosine of x, and we'd like to create a polynomial approximation of cosine of x centered at 0. Because Maclaurin polynomial means that this center point is 0. We want a 6th degree, meaning we're going to compute until we get to, we want x to the 6th term. So here we go. Our polynomial should have the same value at the center as our original function. So in this case, that's f of 0 is cosine of 0. Cosine of 0 is 1. We need to know what the derivative of our function is. That's, in this case, minus sine. And we need to know what the derivative at the center, in this case 0. Sine of 0 is 0. Continue until we get to the x to the 6th term, or the 6th derivative. But since this is cosine and sines, this shouldn't be too bad. Second derivative, derivative sine, minus sine is minus cosine. That means the second derivative at 0 is minus 1. The third derivative of x, derivative minus cosine, is sine. So the third derivative at 0 is 0. The fourth derivative, sine is cosine, and now we're back to the beginning. So we could continue on our pattern here. We know the fourth derivative is 1. Fifth derivative is sine, or minus sine. So the fifth derivative of 0 is 0, and the sixth is minus cosine. So the sixth derivative at 0 is minus 1. This tells me these values are everything we need in order to fill in the recipe for a Maclaurin polynomial. So we want a Maclaurin, we'll use capital M for Maclaurin, 6th degree. Should be 1 plus 0, the first derivative at the center over 1 factorial times x to the first, plus the second derivative at the center over 2 factorial times x squared, the third derivative over 3 factorial times x cubed, plus the fourth derivative at 0 over 4 factorial times x to the fourth, plus the fifth derivative at over 5 factorial times x to the fifth, plus the sixth derivative over 6 factorial times x to the sixth. And note all these zeros don't matter. So simplify this, this should be 1 minus 1/2 x squared plus 1 over 4 factorial x to the fourth minus 1 over 6 factorial x to the sixth. Try this again, this time with a Taylor polynomial. So same game, just the center will not be 0, it'll be something else. In this case, the center is 1. 4th degree, so we're going to go until we get to the x to the 4th power. And our function is the natural log of x. So let's see. The function's value at the center, so I'll plug in c, in this case it's 1. The natural log of 1 is 0. See, the derivative of our function, derivative natural log is 1 over x. So the derivative of our function at the center, which is 1, is 1 over 1, which is 1. The second derivative of our function is, see, derivative of 1 over x, that's x to the minus 1. bring the minus 1 down, and then lower the exponent by 1. So that's minus 1 times x to the minus 2, or minus 1 over x squared. So the second derivative at the center is minus 1 over 1, which is minus 1. The third derivative is the derivative of this, so negative 1 times x to the minus 2, bring the minus 2 down and lower the derivative to minus 3. Minus 1 times minus 2 is positive 2 over x to the third. So the second derivative at 1 is minus 2 over, or is 2 over 1, which is 2. And finally, the fourth derivative. Same game, bring the minus 3 down. Minus 3 times 2 is minus 6. So the fourth derivative at 1 is minus 6 over 1, which is minus 6. Put this together, the Taylor polynomial of degree 4, centered at 1, should be the value of the polynomial at the center, plus the first derivative at the center over 1 factorial times x minus the center square to the first power, plus the second derivative at the center over 2 factorial times x minus the center squared, plus the third derivative over 3 factorial, the third derivative is 2, over 3 factorial times x minus the center to the third power, plus the fourth derivative, which is minus 6, over 4 factorial times x minus the center to the fourth power. So I'm simplifying. Note that 3 factorial is 3 times 2 times 1, and the top here is 2. So the 2's will cancel, and you'll have 3 times 1 are just 1 over 3. So maybe a more simplified way to write this would be the Taylor polynomial should be 0 plus 1 times x minus 1 minus 1/2 times x minus 1 squared, plus, we just said this, 2 divided by 3 factorial is 1/3, x minus 1 to the third power. 4 factorial is 4 times 3 times 2 times 1. 6 is 3 times 2 times 1. So the 3 times 2 times 1's will cancel, and we're left with just a 4 and a minus. So well, minus 1/4 x minus 1 to the fourth.